Okay, this is on proving segment relationships, and we've had several postulates already. As we go through, future chapters, we're going to add to that list. Okay, so we did up to postulate 2.8 the other day. Now this is postulate 2.9. Okay, and it has a special name. It's called the segment addition postulate. Okay, and it says if point B is between points A and C, then AB plus BC equals AC. This is what the picture would look like. If I said this is A and point B is here and point C is here. If B is between A and C, then the measure, and without that segment line above it, it's basically talking the measure. The measure of AB plus the measure of BC equals the measure of AC. And that's the special name for segment addition. Okay? Okay, now I want to go through an example of a proof. Okay? And they will ask you, in this one they ask you to prove. It says, given the measure of PQ equals RS, prove PR equals QS. Okay, and usually when you're doing these in the book, the author gives you a picture. Okay, so you got to look at the picture that they're giving you. And on this one, label this as point P. Label this as point Q. Over here we have R, and we have S. Okay, now one thing you want to do when you look at the pictures, if you look at that picture and look at what we're trying to get to is PR, that's this whole thing, and QS. What's the part in common in both those? The PR and the QS. What's in common in both parts? Where's the overlap? QR is the overlap. So a lot of times on these pictures you got to look kind of ahead. There's an overlap in here. PR is this whole thing, QS is this whole thing, there's an overlap. Okay? Okay, so now let's do the proof. So you always want to look at the picture if they give you one, and usually they do. Okay, and remember this is statement and reason. The good thing with geometry is you always have to back it up. If you're going to write something down as a statement, you have to back it up with something. Okay? Okay, the first thing I do is the given. And if you look at the book, you don't have to always, like sometimes there's more than one part on the given. You don't always have to put the given all on the first line. Okay? Some of it might come later in the proof. Okay? So this one, the reason would be given. Okay? Okay, second step. Okay, I'm going to use that PQ plus QR. Okay, now look at your picture. PQ plus QR equals RS plus QR. Now look at your picture and look at what I did. You got to look from this line to this line. What did I do? What did I do there? I added QR on both sides. What property? Addition. And if you have to, if it helps you, taking notes, basically all we did there was we added QR to both sides. Okay? Okay, PQ plus QR equals the whole thing, PR. Right? This would have been better up here. You guys, I'm gonna change this around. I'm gonna go the other order. QR. It's gonna make it easier. QR plus RS. I still added. Okay, still added QR on both sides. Okay. And then if you look at this, QR plus RS equals the whole thing, QS. Makes the order better. Okay, now what property says this measure plus this measure equals the whole thing? Segment addition, AB plus BC equals the whole thing. So this is just segment addition. And notice, it's okay to do the same, like I could write out step 4 for this, but it's the same thing. So I can do it on one line. This is segment addition. Okay. Okay, now come back up here a minute. PQ plus QR. PQ plus QR equals what? PR. Okay. QR plus RS equals what? QS. What property says I can put those in? Substitution. Now, did we get to what we were trying to prove? Is it in the right order? Yeah. If it was not in the right order, I'd go one more step. I'd say QS equals PR, and that's symmetric. But it's already in the right order. You're done. Okay? Questions on that one? Okay. Another theorem. They give you another theorem. We've had a new postulate. Now this one's a new theorem. Okay? Theorem. The only theorem we've had so far was 2.1, and that was the midpoint theorem. Now this is theorem 2.2. Okay? What's that? We had that. Yeah, we had that earlier. Yeah. Okay, this is what they call segment congruence. Now, when they're talking like PR up here, that's the measure of PR. When they're talking segments, they're going to put the line segment above it. Okay, segment AB. When you read this, you ought to read it. Segment AB, and this symbol is congruent. Segment AB is congruent to segment AB. The other day we did the properties of equality, and one of the properties of equality was like 5 equals 5. What's the property that says anything equals itself? Reflexive. Okay, so the difference is that was properties of equality for real numbers. This is properties for segments. But it's still reflexive. It's just that it's dealing with segments. This is still the reflexive property. Okay? The other one we had was if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. What property was it that says if A equals B, then B equals A? Symmetric. That was symmetric. So this is the same thing. Same idea. This is symmetric. If segment AB is congruent to CD, then CD is congruent to AB. They just turn around that congruent symbol. Okay? And the last one, you can probably guess, is transitive. If segment AB is congruent to segment CD, and CD is congruent to segment EF. You need the segment above each one of those. Then, okay, what would my conclusion be? Turn around. Turn around. Yeah, AB is congruent. Yep. Good. AB is congruent to, okay, EF, segment EF. So it's like this. If A equals B and B equals C, then A equals C. Okay? It's got to be in the right order, and that is transitive. What we did the other day was for real numbers. This is for segments. Okay? Okay, and then a property that you will use a bunch is called, and it's actually a definition. It's not a property. Sorry, it's a definition. And I'm going to abbreviate it. Definition of congruent segments. The definition of congruent segments. You're going to see this one a bunch. Okay, definition of congruent segments. And it says if segment AB is congruent to segment CD, you got to have the lines above those because those are segments, then the measure of AB, that's like the length of your line segment, equals the measure of CD. Okay? Here's the difference. Segments are congruent. Measures are equal. Okay, so let's put a little note there to help you remember that. Segments and angles. Whoops. Segments and angles are congruent. Distances and measures are equal. They're basically telling you which symbol to use. Okay? Segments are congruent. Measures are equal. Okay? Okay? Okay, I want to go through another example of a proof. Okay, say you're given segment MN is congruent to segment PQ, and PQ is congruent to RS. Segment lines above all those. Prove MN is congruent to RS, and those are segments also. Okay, now here's the picture that they give in the book. MN, label this as M, this is N. Same length over here. Try to draw out the same length. PQ. Okay, and over here, same length. R and S. Okay, so we're given that M and N segment MN is congruent to PQ, and PQ is congruent. So we could even do this. This is congruent to this. Is congruent to this. What they want you to show is MN is congruent to RS. Okay. Okay, so let's go through 2 columns. Still statement and reason. Okay. So MN, segment MN is congruent to PQ. PQ is congruent to RS. Okay, and that's given. Now we need to get down to MN is congruent to RS. Okay? Okay, before you can just jump to the segments being congruent, you got to get their measures. Okay, so MN is equal to PQ. Okay, and PQ is equal to RF. Okay, so now you got to look from this. MN is congruent to PQ, and MN equals PQ. What properties goes from here to here? Does that look like it? We went from the segments being congruent to their measures equal. Okay? Definition of congruent segments. Okay? Nope, these are measures. Okay? Andy, we're going to here, right? From this one to this one. So the lines are gone. Okay. Step 3. Step 3. Look up here for a minute. MN, like A equals B, B equals C. What would I want down here? Okay, so I want which letters? MN equals RS, right? And what property? Look at it again. A equals B, B equals C, A equals C. That's transitive. So you have to look at all the different parts. And we'll go from one line down to the next line. Okay, now you got their measures equal. Now you can go back to the segments. MN is congruent to RS. What property says if the measures are equal, the segments are congruent? It's not a property. Yep, definition. It's that definition again. Definition of congruent segments. Okay. And you're done. Now, are these in the right order? MN is congruent to RS. Yeah, you got to always go back and look at that. They have to be in the same order. If they're not, then you're probably going to use the symmetric property to switch them. Okay? Okay, last example. Okay, let's say you're given segment JK is congruent to KL, segment KL, and HJ is congruent to GH. And one more thing, and KL, segment KL is congruent to HJ. Okay, it's given JK, segment JK is congruent to KL, segment HJ is congruent to GH, and KL is congruent to HJ. Okay, prove. G, that's a G. Sorry, G, segment GH is congruent to JK. Okay, now they give a picture. Okay, you always want to look at the picture, what they're giving you. Okay. Okay, label this vertex as J. Right about in the middle, label this K. Label the endpoint L. Right about in the middle, put that as H, and this one is G. Okay. Okay, so if you look at those segments, look at the picture. JK is congruent to KL. HJ is congruent to GH. Okay, and KL is congruent to HJ. What we want to get to is GH. That segment is congruent to JK. Okay? Okay, two-column proof. Okay. For the first part, I'm only going to write down the JK is congruent to KL, and KL, that segment is congruent to HJ. I want to give you an example of all the givens. Not, you could write down all the given on step 1. On this one they don't. Okay. Okay, now look up here for a minute. Here's the reason they don't write it all down at once. Everybody look. Okay, if JK is congruent to KL and KL is congruent to HJ, then JK is congruent to, by what reason? What property? If A equals B and B equals C, then A equals C, what property? Transitive. Okay, so their step 2 would be, you look at it again, JK is congruent to KL, KL is congruent to HJ, then JK is congruent to HJ. That's transitive. And that's the only reason they don't write down all 3 of those in the given, because it's easier to see that. Okay? Okay? Then on the next line, the author has the author has HJ. Look back up here at the given. Which one did I leave out? This one's there, and this one's there. So I need this one. Okay? I need the other one in the middle. I left it off. So HJ is congruent to GH, those segments. So that's still given. Okay? Okay, now look again up here. JK is congruent to HJ, but HJ is congruent to GH. So JK is congruent to which property? Still transitive, yep. So JK is congruent to GH. Still need the segments on all those. Okay? And that was still transitive. Anybody having trouble seeing that? You need me to point to it again? Okay. We're trying to get, look at what we're trying to get to. How close are we? Yep. Symmetric property. Turn it around. So we'd have GH is congruent to JK. And that is symmetric property. Symmetric says if A equals B, then B equals C. Same idea. Okay. So it's JK is congruent to GH, then GH is congruent to JK by symmetric. Okay. Okay. That gives you a few more examples on the properties. Okay, now everybody listen up. So you, on the, okay, on 2.7, there's one back on page 362, number 24. Okay. Even if it's a fill in the blank proof, I want you to write it all down. It's just easier for you. You'll have something to study, and it's easier for the grader. Highlight or double underline or circle your, if it's fill in the blank. Okay, now, everybody listen up, okay? On those, on the proofs for Monday, I want everybody to do them, to try them. Even if it's just an original and there's no It's not fill in the blank. Okay? I am not grading this assignment on Monday. Now, is that sending the message this assignment's not important? No, it's sending the message, I want you to try this without sending you into a royal panic. Okay? I want you to try it. Okay, but I'm not going to count it against you on Monday. We are going to go through it on Monday. But if you don't spend the time to go through this and try it on your own, you're a day behind on proofs. Okay? You have got to try to do these. Okay? There's no way to get these without trying it step by step. Now, I also sent the message earlier, just because Kelsey does the problem one way, does that mean Kenzie's is wrong if she did it a different way? No. You just got to go line by line. And when I'm grading those, I go line by line and say, where does it fail? If it doesn't fail and you get all the way down there, then it was okay. But if you can't justify your step with the correct reason, then it fails. Okay? Okay. So write that assignment down. Okay? You don't have a whole lot of time right now, so that means over the weekend, okay, you got to give some good effort on that. But we are not taking a grade on it. You will actually grade your own. You'll go through your own on Monday. Okay? But you have got to try it. Okay? That way there's not so much panic. Okay?